College Algebra, Topic 5.5, Application of Logarithms and Exponential Functions. First, we want to find the hydronium ion concentration of pure water. Well, that comes from the pH formula. The pH formula is a logarithmic formula, which is pH equals the negative common log of the hydronium ion concentration. Okay, and pure water has a pH of 7. So we'll put 7 in here, equal to negative log H3O. And now we want to solve for the hydronium concentration. First, we'll get rid of the negative and then the logarithm, and then we'll have what's left will be the hydronium concentration. So we'll multiply both sides or divide both sides by -1. This gives me negative 7 equals the common log of the hydronium ion. So in other words, that's 1 down and 1 to go. To get rid of the log, we're going to use one of our properties that converts logarithmic equations to exponential equations. So first we need the base, which is base 10. This over here becomes the exponent, negative 7. And this now will equal the hydronium. Alright, now to the negative 7th power, or 10 to the negative 7th power, is the equivalent of having 6 zeros behind the decimal. 1, 2, 3, 4, 5, 6, and then the 1 here. Very small amount here, but this is the hydronium concentration, given that the pH level is 7. Now, next is how many years should money be compounded weekly at a rate of 12% to double any investment? Well, since we're compounding weekly, the formula will be A equals P 1 plus N, R divided by N, all to the NT. Now, A is the yield, P is our principal, R is the rate, N is the number of times compounded per year, and T is the number of years. Okay, for T, since we're looking for how many years, T is unknown. N, since it's compounded weekly, there are 52 weeks in a year, so it'll be compounded 52 times. The rate is 12%, so we'll put 0.12 here. The principal was not given, so we'll put P for principal. And we're trying to get a final amount that's double the investment. Well, the original investment is P, then the output will be 2P. That's doubling the original investment or principal. Okay, now let's put all these in here. So A becomes 2P, P remains P, and this will be 1 plus 0.12 divided by 52, all to the power of 52T. Okay, I want to simplify the base here, so we'll get 2P equals P, and let's see, 0.12 divided by 52, a lot of decimals on that, so 1.002307 and 7, okay, and to the 52T power. Alright, now we're going to divide both sides by P, so we're solving for T, so first we'll get rid of the P, and then the base, and then the 52. So first divide by P, we get 2 equals the base of 1.00230777, all to the power of 52T. And next we'll get rid of the base by converting this into a logarithm. So this will be a log with a base of 1.00230777 and an input of 2, or argument of 2, and that will all equal 52T. Lastly, I want to divide everything by 52, and this will get my T by itself. Okay. Alright, so what we have here is a log with this base 1.00230777 of 2. Using my my change of base formula, I will take the natural log of 2 divide that by the natural log of the base 1.0023077, and I'll divide that answer by 52, and that'll be my time. Okay, so let's begin that process here. Okay, natural log of 2, and divide that by the natural log of 1.0023077, and we'll close that. Okay, there's my result, and I want to divide that by 52, and we'll get a time of 5.8 years. Okay, so probably about maybe September, 5 years, and maybe up to September to have this type of yield. Okay. How many years would it take to become a millionaire by investing $2,500 compounded continuously at a rate of 12.5? Okay, well, continuous compounding would be A equals P base E to the RT power. Okay, then we need to find out what A is, what our P is, what the R is, and the T. Okay, the time, years is unknown because we're looking for that. The rate will be 0.125, that's equivalent of 12.5%. The principal, the amount that was put in originally, will be the $2,500, and the amount that we want, since we want to become a millionaire, we want to put a minimum of $1 million. Okay, so that will be 1 million equals 2,500, and that'll be E to the 0.125 and T. Okay, now we'll begin the process of solving for this. So we'll get rid of the 2,500, then the E, and then this coefficient on T. So step 1, removing the 2,500. So we'll divide both sides by 2,500. Okay, and what that'll give me is, okay, 400, and that's equal E to the 0.125 T power. Okay, next, get rid of the base of E by converting this into a logarithmic function. So this will be log base E of 400 equals 0.125 T. And thirdly, we want to get rid of the 0.125, so we divide by 0.125 on both sides, 0.125. Okay, now log base E is natural log of 400 divided by 0.125. Okay, so let's figure that out. Let's see here. Natural log of 400, close parenthesis, divided by 0.125. And that's going to be about 47.9, let's round it up to about 48 years. So T is approximately 48 years it would take to become a millionaire when investing $2,500 at a rate of 12.5%.